Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology. In this problem, we will calculate the relative permeability of the medium by using the given data. Now here again these are the problems based on the simple basic definitions of the magnetic circuit. I will read out the problem and we will sort out the given data. An iron ring has a mean diameter of 15 centimeters. This diameter of the ring is given, which is given as a 15 centimeters, that is 15 into 10 raised to the power of minus 2 meters. And the cross sectional area of 20 centimeters square. Area is given, which is given as 20 centimeters square, that is 20 into 10 raised to the power of minus 4 meters square is the area. The radius of the air gap is given. This here, if the air gap it is one pole, and this is the other pole, and this air gap is circular, then this radius is given. This here its double value will be the air gap or length of the air gap. Now here the length of the air gap is, the radius of the air gap is given as 0.5 millimeter, means it's double, that will be 1 millimeter, means this is 0.5 into 10 raised to the power of minus 3 into 2 will be, that is 1 into 10 raised to the power of minus 3 meters will be the length of the air gap. Then here the ring is uniformly wound with 1500 turns, means number of turns are given here, which is given as it is 1500 are the number of turns of the insulated wire. The magnetizing current of 1 ampere, means here in this case the current is given, which is given as the 1 ampere. Produces the flux of phi is also given, which is given as 1 milliweber, that is 1 into 10 raised to the power of minus 3 webers is the flux in the air gap. Calculate relative permeability of the iron core, means we are interested in the calculation of the mu r value. Now here the procedure is the same as the previous, but here only the calculation parameter is different. Means how is the case? We have an iron ring with an air gap. Again, the magnetic circuit is simple, which is not the complicated circuit as we have discussed in the previous example maybe. Now here, this is the iron ring having something diameter is given and it has an air gap of that is 0.5 radius, that is 0.5 millimeter is the radius, means length of the air gap is 1 millimeter. Means here, this is 1 millimeter is the air gap. Now what is given thing? Average diameter is given or mean diameter is given, which is given as 15 centimeters. Means here this diameter is given, which is the 15 centimeter is the mean diameter is given. Then here cross sectional area, if I am cutting here its cross sectional area, I am showing by shaded portion, it is given as it is 20 centimeters square, that is 20 into 10 raised to the power of minus 4 meter square is the cross sectional area. And here in this case, here is the winding, it is something like this, and we are applying the MMF here. This MMF, in that particular case the current in the circuit is 1 ampere and here it has 1500 are the number of turns. Then we are interested to calculate mu r, that is relative permeability of that particular material, which is the iron ring. Now here in this case, how is the case or how we will deal with this particular problem? Now here in this case again we have the two formulas for the calculation of the MMF. One formula is MMF is equal to N into I is 1, and here another formula is MMF is equal to phi into S. Here in this case the I is given and number of turns are also given, that is N is given here, this value N is given, and if both values are given directly we are able to find out this MMF. Means here if this MMF is known, phi is also given, means we have to calculate S, and by calculating S, formula for the S, we have the two S. That is one is that is reluctance of the air gap and other is the reluctance of this path. And for the reluctance of the that is relative permeability of the air gap is 1. Is here we have one equation, one unknown for the S, and we are able to calculate its value of the reluctance of the magnetic path. I will start from this first step and then we will go for the step number 2. Now here the MMF is equal to N into I, that is N into I, which is equal to N is the number of turns, which is 1500, into I is the current, which is equal to 1500 ampere turns. This is 1500 ampere turns is the MMF. Now secondly, we will focus on the calculation of the S here. We will focus on the calculation of the S. Now from this formula, S is equal to MMF upon phi. Therefore here S is equal to, that is MMF divided by its flux, which is phi. If I am working on this calculation, MMF is, which is 1500 divided by flux, which is 1 into 10 raised to the power of minus 3, which is equal to, if I am working on this calculation, its value it is found to be, that is 1.5 into 10 raised to the power of 6, it is ampere turns per Weber. This is ampere turns per Weber is the value of the S, that is reluctance of the magnetic path. Now here, similar to the electrical circuit, here if we have the electrical circuit, I will use this particular portion, and if we are interested to calculate the reluctance of the resistance of the circuit, then this is R1 and R2 is here. This is the reluctance of the core and this will be the reluctance of the air gap, because it is a series kind of the circuit. Then here this is R1 and this is R2, means we are interested to calculate something, a calculation of the rho kind of thing in case of the electrical circuit. Here we will go for that calculation. Now here the reluctance S, which is equal to this total reluctance S, its value is already known. Now here is equal to reluctance of this iron ring, that is S of iron plus S of the air gap, which is equal to, this value is known as, which is 1.5 into 10 raised to the power of 6 is the total reluctance. S for the iron is formula is, it is L divided by A. This is L of the iron, that is length of the iron path, divided by, it is A into that is mu into mu naught, or it is mu naught into mu R, because L divided by A mu naught into mu R is the formula for the S. This value plus length of the air gap divided by area is the same for both, into it is mu naught, because relative permeability for that particular case is 1. This is very same as length of the iron path, which is given as, here its length is not given. I will calculate its length first, because here in this particular case its diameter is given, and if we are going to calculate the length of that path, this length of this iron, I will neglect this 1 millimeter, is equal to, it is pi into d. It is pi into d, which is equal to, pi is the constant and d is the diameter, which is 15 centimeter. That is into 15 into, it is 15 into 10 raised to the power of minus 2. And if we are working on this calculation, its value, it is found to be, in this particular case, its value, it is found to be, that is pi into, otherwise I will substitute this value as it is, that is pi into 15 into 10 raised to the power of, it is minus 2. I will substitute that value. Now here, this length of the iron, this value, length of the iron path, which is, I will substitute, that is pi into 15 into 10 raised to the power of, it is minus 2, divided by area, which is this, that is 20 into 10 raised to the power of, it is minus 4, into mu naught, which is 4 pi into 10 raised to the power of, it is minus 7, into relative permeability, in which we are interested. We are interested in this mu r. I will use a different color here, plus the other values, length of the air gap, which is 1 millimeter, that is 1 into 10 raised to the power of minus 3, divided by A into mu naught. A is again same, that is 20 into 10 raised to the power of minus 4, into mu naught is, it is 4 pi into 10 raised to the power of, it is minus 7. If we are working on this calculation, here this value will be the same, if I am going this side, and in that case here, otherwise I will keep the values as it is, which is equal to this value, that is pi into 15 into 10 raised power of it is minus 2. This total divided by 20 into 10 raised power of it is minus 4 into it is 4 pi into 10 raised power of minus 7 into the same value, which I will use again the different color here, which is the mu r, that is relative permeability. We want to find out this value plus this calculation, and this whole calculation is coming to be, it is 397.887. This is 887 into 10 raised to the power of 3 is this value. Now here with this calculation, if I am shifting this value on this side and then we are doing the subtraction, then here its subtraction is found to be, that is 1.102 into 10 raised to the power of 6. This is equal to the same value, that is pi into 15 into 10 raised to the power of it is minus 2. This total divided by, this is 20 into 10 raised to the power of minus 4 into it is 4 pi into 10 raised to the power of it is minus 7 into its relative permeability, which is the mu r. This is mu r. We are interested in the mu r. That's why if I am substituting that value, this is mu r on this side and remaining all values on the other side, then this mu r is equal to, this is pi into 15 into 10 raised to the power of minus 2. This total divided by 20 into 10 raised to the power of minus 4 into it is 4 pi into 10 raised to the power of it is minus 7 into this value. I will shift here. This is 1.102 into 10 raised to the power of it is plus 6. And if we are doing all these calculations here, its relative permeability, it is found to be 170.145, and this is unitless parameter. That's why its value is 170.145 is the value of the relative permeability in this particular case. Thank you for watching this video, and in the next case I will increase the level of difficulty for the problems, and we are able to, or we will go for another calculations which are related to this case. Thank you.